All right, so 2.6 is technically called proving geometric relationships, but really what it boils down to is we're going to be doing a lot of the same kind of stuff as we did in the last section. It's just more further practice with it. And it's going to include a new type of proving things instead of the two-column way of doing it, called a flow proof. And my hope is that a flow proof might make things a little bit easier for you. I don't know. Some people like them, some people don't. So if you like to stick with the two-column instead, that's okay. But it's at least giving you a little bit of exposure to it, so maybe that will help. And we'll do some more proofs together, okay, just to kind of continue to get some more practice in this. We'll keep the training wheels on with me for a little while, and then we'll take them off for a little while and let you try it some more. So before we move on, though, there's a few more theorems and postulates that I want to at least highlight, and we're just going to write briefly into your notes here to start off with, because we're going to use some of these in this section too. So the first one, and these are all things that you can start writing into that packet of theorems and postulates. These are all ones that are included in there, so if you'd rather just jot it right into that, that's true. That's fine too. Just remember to keep adding in all the other ones as we go along. But the first one, Theorem 2.3, this is a pretty easy one. This is called the right angles congruence theorem. And the right angles congruence theorem simply states all right angles are congruent. Now this one is one of those where, yeah, it seems kind of obvious, but it actually saves you some time. If you were going to actually prove that if you had two right angles in a picture and you had to prove that they were congruent, what you'd have to do is to say, okay, I know that because I have a right angle, its measure is 90 degrees. I have this other right angle. I know because it's a right angle, its measure equals 90 degrees. Because they're both equal to 90 degrees, I know that their measures are equal. Because their measures are equal, then I know that they're congruent. You don't have to do any of that anymore, and now you can just say, that's a right angle, that's a right angle. Congruent. Let's try to do it really quickly. Can you guys come back in a little bit? All right, thank you. Okay, so basically this is allowing you to do what you've wanted to do in a proof involving right angles, and that's if you see two right angles, you can just automatically say they're congruent and not have to do all that other gobbledygook I just said really fast. Okay, so that's that one. The next one, Theorem 2.4. It's one we're going to be looking at here a little bit. This is the congruent supplements theorem. And we've actually already done some proofs that have involved this type of a thing, and we had to go through all these tedious steps to get through it. Well, now that I'm writing it out as a theorem, kind of like this last one, now you can just say, oh, I know that I've got two angles that are congruent because of this congruent supplements theorem. And what it says is two angles that are supplementary to the same angle are congruent. So on that sheet, remember there's a place to put a little picture too? So I'll do a little picture on this one to help you out too if you're having trouble visualizing what exactly this thing is saying. So let's say I've got, here's angle 1, here's angle 2, and here's angle 3. So what that says is, if I know that 1 and 2 are supplementary, they add up to 180, and I know that 1 and 3 are supplementary, they add up to 180, then 2 and 3 have to be exactly the same. Okay? That's what that theorem says. And so that's going to be useful now in some proofs, where you don't have to do all the tedious little steps to show stuff in the middle of that. You can just say, if I know measure of 1 plus measure of 2 is 180, and I know measure of 1 plus measure of 3 is 180, automatically 2 is congruent to 3.
So it's
Yeah.
just not explaining all the steps that you take to do that.
Right. Remember, a theorem is something that could be proven, right? And so, yeah, there are lots of little steps that could prove this, but now that I have it written as a theorem, the power of it being a theorem is now you're allowed to use this in a proof. So now instead of doing all those little steps, I can just say, I know it's true because of theorem 2.4. There's my justification. Done. I'm not going to put all those little steps anymore. I'm serious, bro. Okay, so you're going to be happy there's a couple more coming then probably. The next one, theorem 2.5, very similar to 2.4. This is the congruent complements theorem. And basically, it just states that two angles that are complementary to the same angle are congruent. Okay, I'm not going to draw a little picture for this one, but you can. It's basically the same idea as the last one, except the angles would add to 90 instead of adding to 180. But if I have two angles that add up to 90, and then another set of two angles where one of them is the same that add up to 90, then those other two are going to be the same. Same way the last one worked. Yeah, maybe so. Other ones we're going to use, 2.8 and theorem 2.6. So yeah, this one's a postulate, which remember just means we can't actually prove it, but this will be something that is useful. So the linear pair postulate says if two angles form a linear pair, they are supplementary. Okay? What we probably would have said in the past simply was definition of a linear pair. It is technically a postulate. So if two angles form a linear pair, then they are supplementary. And so really what I will accept from this point on is if you're going to use it, if you want to say definition of a linear pair, or if you want to say postulate 2.8, I'll take both. I really don't care. It's fine. But that's what it says. And then theorem 2.6. This one we'll use quite a bit. This is the vertical angles theorem. And this one simply states what we already know about vertical angles, but now here's a way that we can use it in proofs, is vertical angles are congruent. Okay, so, yep, something we already knew, right? If you have two lines across forming vertical angles, they're going to be the same measures, which means they're congruent, but now we can just use the vertical angle theorem and boom, got it. Okay, so we're going to do a proof together here now. We're going to be looking for places we can use these theorems we've just talked about to help kind of shorten things up. Okay, I'm going to do the proof, regular two because you're used to that, and then I'm going to show you how you could take that and then turn it into what's called a flow proof.